So, we're still talking about dead stars. That's basically all we're going to be talking about the rest of the semester, just stellar corpses. And last time we talked about white dwarfs, which is what all the low mass stars become when they die. And then we started to talk about what happens when high mass stars die in a supernova. Depending on how much material is left over in that core, you're either going to get a neutron star or a black hole. And it's just the mass that's left behind that determines which one you're going to get. If you leave behind less than 2 to 3 solar masses, you have a neutron star. But if you leave behind more than 2 to 3 solar masses, you get a black hole. Okay, so what we're going to be talking about today is black holes. We're going to mainly talk about what exactly they are, because they don't work exactly like they don't work almost at all like they do in sci-fi movies. So let's talk about this. Now, all of this has been talking about gravity, right? What does gravity want to do to a star at all times? It's kind of a repeat question. What does gravity want to do to this leftover dead star, no matter what kind of dead star it is? What's that gravity trying to do? Crush it, right? Gravity is trying to crush it, okay? And when is gravity satisfied? When does gravity decide that enough is enough? Never, right? It never is satisfied. That's correct. It's never, ever satisfied. The only thing that stops gravity from crushing this dead star is if something fights back. If nothing fights back, then gravity just gets to crush forever, okay? And we talked about this a little bit. In a white dwarf, do you guys remember what's fighting the gravity? There's a certain kind of thing in the white dwarf that becomes degenerate. What becomes degenerate in a white dwarf? Somebody's saying fusion. Fusion is what fights gravity throughout the life of a star. But remember, once it's dead, it has to rely on other things. Yeah, in a white dwarf, the electrons become degenerate, and they fight gravity with the power of their self-hate, right? But in a neutron star, it's already crushed too tight for the electrons to do anything, right? It's crushed too tight for the electrons to do anything. So what fights back in the neutron star? What becomes degenerate in that type of dead star? Because the electrons can't fight anymore. So what becomes degenerate in a neutron star? Yes, the neutrons. The neutrons. So remember that white dwarfs stop shrinking when they get to be about Earth size because of the power of the electrons fighting. But in a neutron star, because there's extra gravity, it's crushed down beyond that. But it does stop shrinking when it gets to be about New York City sized, because the neutrons start fighting back with neutron degeneracy pressure. But if you have more than 2 to 3 solar masses in that dead star, then gravity is stronger than the degenerate neutrons. And so even the neutrons can't fight back. And so this thing crushes even tighter. But the problem here is that now this object is going to have so much gravity. The gravity is so strong that nothing will be able to fight again. So a black hole is an object that is crushed so tight that its gravity at its surface is so high that nothing can fight it ever again. Okay, so if I asked you what fights gravity in a white dwarf, it's the degenerate electrons. If I ask you what fights gravity in a neutron star, it's the degenerate neutrons. But if I ask you what fights gravity in a black hole, what is the answer? What fights gravity in a black hole? I'll ask you guys right now. What's the answer to that question? It's kind of a trick question. Yeah, the answer is nothing. Okay? And that's going to get us to something that's going to be very, very, very strange about black holes. Okay? Because whenever something fought gravity in the other kinds of dead stars, that dead star stopped shrinking. So if nothing is fighting gravity in the black hole, does the black hole stop shrinking? Yes or no? If nothing is fighting gravity, does the black hole stop shrinking? Yes or no? And don't worry, you're probably going to get a lot of questions on this stuff kind of wrong. That is totally okay, because this is going to be stuff that's going to challenge your understanding of reality as we go through this. So the answer is no. So here's my next question. No, the black hole does not stop shrinking. Nothing can stop the shrink of gravity in that black hole. So here's my next question. How big is a black hole? Let's see if you guys can figure that one out. How big is a black hole if nothing can stop the shrinking? Oh yeah, it's definitely tiny. It's definitely tiny. It's way smaller than a city. A black hole, even the smallest stellar corpse black hole, which has maybe a little bit more than 2 solar masses, 2 times the mass of our entire sun, is still going to be smaller than a neutron star.